Okay. So today's session will be conducted by uh, John and Debashish. So they are startup founders and who have been working with the Goa State Innovation Council on building their prototype, uh, which is in the domain of missile technology. On behalf of our participants and the Innovation Council, we welcome you, Debashish and John. And
Thank
over,
you, sir.
please start with the session.
Sure, sir. Thank you for the opportunity. Yeah. So, hi, good afternoon, everyone. This is Debashish Doki. A small introduction about us. My name is Debashish Doki, and here is my partner John, John Srivastav. We are aerospace graduates of 2020, and we came up with a small idea, in the field of defense, which was completely different since I was there in the aerospace. So we came up with an idea where we are working on a product. We are trying to build a product which is a combination of a drone and a missile. So basically, if we reach that, so basically the product name is Dronile, and we'll be coming across it. I'll be telling you more about it. So we'll start with today's lecture, not a lecture, today's session on missile technology guidance and control. And we have prepared ourselves. We have put in a lot of efforts so that we can, deliver something which is new, which is we don't come across such sessions regularly. So we have gone through a lot of research, and then we tried to make it very easy so that by the end of this session you will be understanding what is this, how are the technologies in the defense will be working. Okay. So yeah, so let's start with the first, the missile technology and the guidance and the control systems in the defense area. Okay, John, can you please move ahead with the second slide? Yeah, so in this we'll be moving across we will be moving across with all these chapters. The first one we'll be moving is the Indian air defense systems, where we'll be learning about the technical, not much of a specifications, only the core part, so that you can understand how things go here. Second, um, John, can you start doing it? Yeah, we'll be going forward with the purpose and the functions of a control and the guidance systems, where we'll be learning all the purposes and the guiding systems for a missile, how to commit into a handle sector. Second, where we'll be learning the few things we will be learning here, that is attitude control systems, flight path control systems. Then comes the sensing technologies, to sense out the things out, and then making yourself guiding the missile towards itself. Okay, one second. Yeah, sorry for the inconvenience. Yeah, next comes the sensing technologies, which will be going through the guiding sensors and the control sensors, the actuators. After that, we'll be going towards the phases of guidance. I guess these all things will be looking something different, and what all this, why is he telling all this? So John, we can do one thing. You can move ahead. We can show them the list of what it is we are going through, and we can start with the approach of the first session itself. As I can say, these are the phases of a missile from its start to the terminal, that is till the end. We'll be seeing how things go here. Also, then John will be taking to you to the tour of control guidance missile, how to guide it, how to go ahead. Then comes there are different parts, there are different sectors. I don't want to read it out. You can already see it in your screen. Okay, so we'll start. We'll not waste our time. We'll start with the first one, that is Indian Air Defense System. Okay, so Indian air defense systems, to be honest, Air Force is one of the biggest thing. Indian Air Force is one of the biggest in across the world. So how do you think they safeguard us? How do you think they are handling each and every problem that is coming around? And there are different aspects. There are multi-layer air defense systems. When I say multi-layer air defense systems, it's why, because see, India is a huge country. Everything cannot be determined through your, whenever you see something and you take an action. There are things where you have to take actions earlier. Because I'll just give an example. there are a lot of interception threats that come around. When I talk about interception threats, it is maybe giving a small example, Pakistan or China is releasing a missile towards us. So how do you understand? If you understand, when you see a missile just in front of you, you can't do anything. You're gone. The country is lost. So there are certain interceptors which are been built here so that it can be a long range or a short range. So it depends on us so that it protects us against everything. So we'll be coming towards the how the kilometers, how the distance matters, what are the missiles we use for a particular distances. We'll move ahead with that. So can you go ahead with the John? Yeah. So this is where you can see the multi-layer defense systems. How does it look? Before I start with this, please let me tell you, this is just an example, and we are not breaching into any security defenses of our India. It's just an example where we are trying to show you if these are the areas where there is, these are the circles which you see, the red, these are the multi-unit, this is the multi-layer air defense systems. These are the units at different places. Why is it more into sides like north sides? Because it's near the Pakistan and the China. We try to make it more understanding. That's the reason why these are the circles we have made, and these circles will be magnifying, and we'll see what are these circles actually. Okay, so let's go ahead, John. Yes. So do you okay, now perfect animation. Now I guess you might be getting a small idea about what is this. This circle was representing the range. Okay. Guys, am I going a little fast, or is it okay? You understanding? You can give a thumbs up in or anything in the chat. It will be enough for me to understand. Okay. If there's any doubt, you can ask us in the chat. John is here to help you out also. Okay. So let's start with the range as we were talking about. Let's start from the outermost, that is the range of more than 5,000 to 5,000 and plus. Okay, this is a long range interception. That means if a missile which is coming from a very long range, that is maybe from a different country, maybe from China or Pakistan. So when you get a sensor, you get the information. So there are missiles which releases. Okay, now there are the long range interceptions are the mostly Indian ballistic missile defense program defense systems. Here there are the mostly missiles used are the Prithvi or the Agni. These are the huge missiles which will take care of the missiles or the threats which are coming from the distance more than 5,000 kilometers. Moving a little closer towards the country, that is around 2,500 kilometers. This is intermediate range where you will where the missiles which will be maybe there is a place where they might have released a missile at a range of around 2,500. Maybe they have released a missile near Kashmir, and the range comes to 2,500 or above that. So in that area we'll be releasing an intermediate range, and the mostly missile which Indian defense use is the S-400 Triumph. Okay, let's move ahead. That let's come closer uh, to the borders. Here it's around 100 kilometers. Okay, so in this range we use short range interceptions. Yes, Redmi, you have a doubt? You can unmute yourself, you can ask me the doubt. Okay, might be Redmi wanted to see whether Redmi is working or not. No problem. I cannot see the chat. John, if there's any question, please help me with that. Okay. Yeah.
Yeah, sure.
Okay, okay. So I was talking about the short range interception. Here the missiles used are the Akash and similar kind of missiles which is mostly used here. And the final one, which is the line of sight. It's the very short range interception. Line of sight, the name itself says when you see a threat, you launch an anti-threat. Like you launch a defense system. Okay, most of the manpads and anti-aircraft guns are used. To give a precise example, many might have watched Race 3, if I am not wrong. That is of Salman Khan, who just launched a bazooka from his one hand. So that is a kind of manpad the bazooka is one of the manpad which is used in the area of line of sight. I hope we understood about what are the range, what are the different for different kilometers, how things go, and what are the missiles. Okay, let's move ahead with the other areas. Okay, the most important here is the long range interception missile. Okay, so let me tell you, these missiles have there are around four missiles which are mostly used and which are kept, two on the land, two in the sea. Sea in the sense they can be kept in the submarines or ships or anywhere. Okay, here at the high altitude interception, we talk about high altitude interception. That is, first, the whenever we get an information that okay, there's a missile coming from a long range, so the first thing that does is the Prithvi air defense system, the Prithvi is released. Okay, it tries to intercept, or when I say intercept, it tries to go and hit the missile, and to break it out and to avoid the threat. And if it sometimes there is a chance where the missile which is coming as a threat, it just dodges the Prithvi defense system. So now it's a problem. Now it has dodged our missile system. So now it's coming little closer to us. So there are other missiles which are there, which are at lower altitude interception. Okay, which will help us to break through and destroy the missile, which are advanced air defense systems. If in case, as I told you, lower altitude, these are used as a lower altitude. If sometimes the missile which is coming as a threat gets missed by Prithvi air defense, there are lower altitude missiles and advanced air defense systems which will take care of that. Okay, let's go ahead, John, with the further. Yeah. Okay, so from that time, I have been listening to what we have been hearing. What is interception? Interception, interception. Why is this missile called an interception? Okay, so this you can see it's one. It's a Prithvi missile. What is an interception? What is the difference between a normal missile and an interception? Okay, if you can see here, the Prithvi interceptor missiles will be having a lot of sensors in that. Okay, because it's very important for it to understand what are the how the enemy is coming. So for that you need certain parameters, you need certain sensors, you need certain guiding systems. Okay, so here there are, it is like the interceptor missile is always supported by radars, cameras, there are sensors, thermal, so that it can sense the things which is coming around for a particular range. Whereas in enemy missile, what things happen is we guide it, we give him a fixed target. All he has to do is to go and hit it. These are the enemy target. Okay, so this is the basic difference between interception and the enemy. Okay, let's first watch this video, watch something that has been prepared for you so that you get an absolute idea about what am I trying to speak. Okay, perfect. So I guess most of your questions related to interception has been now solved. This is how the interception works. Okay, it is how because this is how an interceptor missile will be calculating based on its system. Okay, and then based on the calculation, it will try to reach out to the speed of the enemy missile and to blast it. Most of the time it gets difficult when the speed of an enemy missile is at other peak, and it has to go under a lot of pressure, like a lot of calculations to attain the actual speed. Because if the thing misses out, there you can see there are assets public which will be the one who will be getting the who has to face the destruction. Okay, so basically solution is the missile interception. Next comes the purpose of function of control and guidance systems. Okay, so talking about this, what is the purpose and how to guide? I'll show you an image of it. Okay, this is an altitude control. What is an altitude control? You might have heard in the physics that left hand rule, left hand thumb rule, right hand thumb rule. Okay, Mr. Galaxy is can't hear. Guys, others, you can hear me, right? I hope others can hear me. Please say yes if okay. Hello, 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 John. Am I audible?
Yes, Devashish, you're audible.
Okay, 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 okay. Fine.
Just ask
Yes.
others if they are.
Yeah. Others, please tell me if you are audible or not, because I don't want you to miss out the basics and then go directly to the advanced. Okay. Okay. Fine. So as I was talking about, okay, as I was talking about the thing here, that is attitude control. So you might have learned about this left hand thumb rule. What is right hand thumb rule? Will be receiving a certificate for attendance. Yeah, we'll discuss about this later. Okay. So yes, the left hand thumb rule or the right hand thumb rule which we use, it's kind of same. Okay. Here we if I show you, if you can see, it's the same, the roll moment, the pitch moment, and the yaw moment. So here, what is a roll means? I'll tell you, roll is a it's a longitudinal axis. Here for the rolling of a flight or rolling of any of the flying object. The pitch moment, if you see the directions has been given to go up and down, maybe it's like the lateral axis, up and like a seesaw. It's the pitch moment. Then comes the movement, which is spinning, that will be vertical axis. Okay. I hope you understood what am I trying to say. These are the three axes through which a flight moves, and we have to take care of this. These are the yaw, pitch, and roll. Okay, let's go ahead. This is about the flight, which we are trying to understand. But how about in a missile? How do you find out the attitude or the all three axes? Okay, the yaw, the roll, or the pitch. Okay, so let me tell you. If you see, it's a symmetric body. The only thing common here for the everything is the roll movement. The Because it walks along the axis, so the roll moment is fixed. But the pitch and yaw cannot be determined, as it is perpendicular to each other. It is the one who is knowing about the accelerometers. They are the person who's working on this, or the manufacturers, or the guided ones who have made this model. They know, like, where do they keep a pitch and a yaw. So there's always a thing that a pitch and a yaw cannot be determined by looking at that. Okay. Okay, fine. So what is an attitude control system? Why is it used? Why are we using these systems? Okay. So the most important thing why it is used is to control. When I say control, it controls everything from the dampings, the fluctuations, the deflections, in order so that to keep the missile in a proper direction, in a proper path, so that it doesn't go out of the path, and you miss the missile or the threat which is coming. So this is the reason why attitude control is being used. Okay, when I say, when I hope this is understood, that it takes care of the damping, it takes care of the fluctuations. There are basically three different types of stability that comes into picture that attitude control looks after. Okay, let's start with the first one. The first attitude system which we look here is the positive stability. So for example, think we have released a missile, and there's a little unstability which we give it to it. So now the missile which is going is now unstable, and then slowly it comes to stability. It gains the stableness, so that this transition of instability to stability is known as positive stability. Okay. Second is the neutral stability. For example, the same way we release a missile and it's going around, then there is we provide an unstableness. So what happens here? The amount of unstableness which we provide, it continues to move in that way only. For example, like if I say about it, so if there is an unstableness, so it doesn't causes more instability. It doesn't affects anything, but it will start moving in that amount of unstableness. It doesn't need anything else. So वो वही पाथ पे चलने लगता है जितना अमाउंट ऑफ स्टेबलनेस दिया गया है, अनस्टेबिलिटी दिया गया है, उसी में रहता है. So ना बढ़ता है ना कंट्रोल में लाता है. Okay, this is a neutral one. So when I say about the final dynamic instability, it's because the dynamic stability, it's when there when a missile is released and आपने एक instability, you provided an instability, unstableness. Yes, yes, sure. You provided an disturbance to it, and now what happens? The missile, it starts getting into unstableness, and here it doesn't maintain like that. It goes on having an unstableness process. So it gets on getting disturbed again and again, again. So this is how it comes. If a missile becomes unstable in the midway, so it doesn't remain capable enough to follow the original path. Okay, to respond to that, that must be ground. There should be, maneuvers. There will be control systems from the ground itself. So that we can help. So for all this, we use attitude control, because if it misses out, it can harm. It can either miss out the target, or also it can go and hit our own area territory. So it's very important to guide it and to control it. So that's the reason why attitude control systems are there, as we have already come across the pitch roll yaw. So let's see the path control, the flight path control systems. Okay, the name itself says the most out of it. It is every object, every missile has been given a certain path. Okay, it's the path to be followed, and it is how it is controlled. For example, if I say the flight path milestone 1, as you can see, okay, now it has a direction. You can see there's an arrow mark, and then there's a second point. Second, so the green part is what is the direction which we have chose to a drone. Similarly, for the flight paths milestone 3 and 4, if you can see, that's a green color path. So if in case if misses out, if you can see, there's a red color line which you see, this is an undesired path. Okay, so now it will disappear. Okay, why? So this is how I'm telling about. This is the path which we have taught, we have trying to see, we are trying to achieve. It is very important for us, to maintain this path, or else there will be an undesired path which will be taken into, which is not into our consideration, and which is a failure. Okay, so let's move ahead with that. Okay, so yes, as I was telling about, the flight path control system defines the flight path, because without a flight path, you cannot reach the destination, you cannot intercept the target. Or so that's the reason why it is very important. So it is controlled, and it works simultaneously with the attitude, it controls with that. Okay, if there is a problem, so if there is a deviation, if there is an undesired route that has been taken, now this will lead to mission failures. Okay, let's come into what is sensing technology. Sensing are the ones to understand how we sense through our sensory organs. It's the same way a missile senses things. Okay, when I say it's a guidance sensors, let's start from below. Okay, so the accelerometer which we are talking about is the one who will be handling the pitch, roll, yaw. Okay, that is the attitude control. When we were talking about that, we understood what is pitch, roll, yaw. So all those will be taken care of with the accelerometers, the LORAN, long range navigation, so that they can, to navigate around and to understand the orientations of the orientations, like if I tell you in a simple way, the transmitters we use so that it can, control the missiles, the transmitters. Second comes the celestial references. As I say about celestials, here it can be a sun, it can be a north pole, anything, a north pole, because sometimes there are systems, all you have to do is just assign the coordinates to that, and it will go on the path and taking the reference of the sun or the celestial bodies. Okay, celestial references. And also let me tell you, there are star trackers in the missiles. Sometimes they use star trackers, which also helps them to reach the point or reach the target with the help of the navigation through the stars. Also, there's Earth's magnetic field, which we know already. That, like, there are a magnetic field through which they understand the position. The television, it's not the TV. It's not basically the TV. It's kind of there where there is an image, kind of image processing comes into picture, or it's, it finds the image. It tries to match. For example, there's a missile going around. It has a camera. Now it will take a picture of the area and it will try to match the picture with the database. Now, if he finds out that the database or the pictures here are matching, so here's where he finds out that yes, we have reached a point. This is the target. We have to make it work. We have to destruct it. So here, this is how the television thing works here as a guidance system. There are thermal imaging. When I say thermal imaging, it's when it senses heat. You might have seen a lot of movies where you see a missile keeps on following a target. Wherever the target goes, it keeps on following. Okay, so there are a lot of Hollywood movies, Bollywood movies, and yes, where all they do is just set the target and it goes behind it, behind it. So how do you think? How does it go? It's because of the thermal sensing. Because when I say a missile following a missile or a target, uh, a missile will be releasing a target missile will be enemy missile, or a target missile will be releasing a lot of hot air, because it uses the propulsion. So hot gas has been released. So the temperature of that particular missile as compared to the atmosphere around it will be higher. So this will help the thermal sensors to understand that, okay, so this is where it's the hottest part and this is moving here and there. We have to follow this and destruct it. I hope it is clear and I'm able to make you understand what I'm trying to tell. Then comes the radar. Yes, we already know about the radar. We have seen Uri movies. We have seen a lot of movies where the radar has been shown. Whenever there's a thing comes into the radar, we get an information. So yes, that is the radios. There are radio frequencies which are used, and finally the cameras to see it and to distract it. So here we have talked a lot about the guidance sensors. I hope this is clear. It's not nothing much difficult. So let's start ahead. Let's go ahead. Okay, let's talk about the thrust vectors. Okay, control and the actuators. What are the controls and actuators? You see there are 4 different things you see in the screen. That is the thrust vectoring, fin control, fin grid control, and the attitude control thrusters. Let's start with the thrust vectoring. It's basically a nozzle. You can see this is the missile, right? The red color part which you see here below the blue color part, it's the nozzle. Okay, here where the exhaust, the basically the compressor and the hot air will be released so that it moves ahead. Here what they do is they change the angle. Okay, and as per the angle, thrust will be moved here and there to control it. See if you can see the first one, the line which you see. Okay, about the you can see the center of gravity here. There is a gimbal angle and the center line. Here the nozzle is moving with an angle so that, and then in the second image you see it is making itself stable. Here to take turns, you to take deviations, you move the nozzles. This is how you do the thrust vectoring. Okay, in order to change the direction of the vehicle, as it also says that. Next, which we are talking about is the fin control. Okay, fin control by a missile. Fin control, which we said, basically every I'll start with the normal plane. You might have gone in set in normal flights, and you might have seen that when there is a takeoff, or when there is a landing, or maybe in the cruising, there is a certain thing which is attached to the wings of a flight. Okay, which moves up and down. Okay, these are the fins. Basically, these are the fins which are used to control the drag on a to control the drag. Drag in the sense when there is a landing of a flight, we take it up so that there's a drag and we reduce the speed of the flight. And it goes down. The fins go down to increase the speed and to gain the takeoff. So next time, whenever you are traveling, just see the fins around your wings, so that you will get an understanding about how you can have a flight, how you can understand that. Okay, the same way in the missile there are fins which are attached, so that it can guide it properly, it can help you maintain on the same path, you can maintain the same direction to move here and there, to move a direction. Okay, next, John, can you share it? Hello? Hello? One second. I'll just share the screen again. One second. Sorry, guys, just one second. I guess John was sharing the screen and there was a slight problem. Just give me 2 minutes. Sorry for the inconvenience. Guys, you can see the screen now. Guys, can you see the screen? Hello, can you see the screen, guys?
Yes, sir.
Yeah, okay, fine. Sorry, I guess he went out somewhere or something happened with this system. So yeah, let's start again. Sorry for the inconvenience. Okay, so we were talking about the guidance systems. I guess he. Yeah, sorry guys. The thing was, John. There was some connection failure suddenly, and John was just out. So yeah, I'll try to share the screen here, and yeah, you will be getting you. Okay. So we have already discussed about the thrust vectoring. Now we were at the fin control, and yes, let's come to the grid. Okay, this is the grid fin control. Okay, so the image, if you see in front, is the image of Falcon 9. You know the Falcon 9, which was released first, which is owned by our famous SpaceX, Elon Musk. So this is something new which came into the picture. If you see, this is the gray color part. It's the grid fin. Okay, it's a kind of fin what they do is, you see the structure of it. Okay, now to control it, it will be moving up and down here and there. So there's you can see a video in the YouTube, it's available. While landing or taking off, there was a this fins started moving up and down here, and then it was trying to adjust. How we'll see here. If you see the image in the left side, this is the fin angle. Okay, which you see the red color line, the fin angle. Here there's a reference line. The green color is the reference line. Okay, here what happens here is when there is an airflow on its top, which is coming, there the air will be passing out. Okay, to the grids. So here, as per the passing out, there will be up and down. There will be changes, so to maintain it into a proper reference. Okay, now this is something that looks cool, if I'm not wrong. So here, this is the attitude control thrusters. Okay, this is the thrusters. um how things go here is, okay, when a missile is made to come into the position to make it stably land it. For example, the Falcon 9, which is making it the Falcon 9 or something, they have the thrusters around it. How? So suddenly when it's the time to land, it will release the thrusters. This is the ignition which you see. It will be done from all the sides to maintain it to get a position. Okay, these are the axes, maybe like the x, y, positive and negative, all these four directions, and as well the x, y, and the between x, y, z. So these all the direction, all six paths is been cleared. They like all six paths, they release the thrusters so that it can go into stable. Okay, now we are at the point of learning what is phases of guidance. Okay, now what are the phase of guidance? Basically, we understand there are phase. Phase means there are certain stages. It is the initial stage, the mid stage, and the terminal stage. Okay, I'll discuss about the initial first. You see the image. I hope it's clear for you. You can see the image. Yes. Okay. The first part is, you see it's written boost phase. I'll explain you why is it written in the next slide. But see, this is the first initial stage or the launch stage. Then is the middle of the stage, which is mediocre phase. It's a middle stage. Then you see in the right side the terminal stage, which is the end of it. Okay, so why do you think these are this like why do you think there is this name called boost stage or everything? I hope you see this picture, you get an idea of it. Okay, okay, let's start. Why am I talking about boost, launching, initial? Why are these names given to it? Okay, as I told you earlier, that there are missiles which are kept not only on land. There are missiles which are kept in with the navy, inside the water, inside submarines, inside. So these are the things which requires to release it from the point of it, like the initial point. We need boosters. Okay, what we say is booster is is it's something ignition. There are, you might have played a lot of games of racing. There is a game, there are features called nitrox. When you click it, it gives a boost, and it certain like it suddenly reaches 100 kilometers per hour extra. Correct. So these are the boosters which are attached to the normal missiles. So whenever in a navy missiles are released, the missiles will be adjusted, which will be it will be having a lot of boosters. So these boosters are the booster components are the one which will be the reason for it to deliver at the place where it can cruise. Cruise means it's hovering, it's cruising towards the target. To make it reach the exo atmosphere from our atmosphere, the boosters are used. Okay, not in every missile, but yes, as I said, it's for the missiles which are there in the navy. It's for that. So what they do is, first the boosters release the missile. Once it's the boosters are over, like the boosters are done, it is dropped out after the complete burnout. Okay, it is the purpose of booster to make it go out of the atmosphere and make it place in the exo atmosphere where it can move towards the target and it can cruise. Okay, so it makes it make places the missile in such a position where it can see the target and it can now handle everything on its own. Okay, so here now these are the main uses of boosters, so that it can guide properly and it can it can make the missile reach at a point where the final terminal stage will be the nearest. As I say, terminal. This is the meteor stage. I'll go to the terminal one later. This is the second stage. There's a meteor stage. This is said to be the longest because here the time, the distance is the most that has to be covered. Okay, this is the place where it has to be very stable. It has to be, because it will be the place where it from where it will be going towards the final stage. So it's a long range that has to be covered. So this is the main phase of a missile, which you might have seen a lot of movies where you can see, while cruising, it's once like they cruise. If you have seen Mission Mangal, where they were releasing, satellites. So there were the boosters which were used for the ignition, sudden ignitions. So these are the things which are used for a missile also to make it guide. This is the final stage, the terminal stage. This is the most important stage. Why? Because this is the stage where everything will be depending on the destruction, the result. Everything depends on the terminal stage. Okay, it has the high accuracy. It has the the response, and the accuracy must be at the top. It's the top priority. So there are some features which are added in the terminal phase, because there can be a situation, just before it hits the target, there are only 2-digit kilometer distance, which is, it's nearing around, and it has to be, it just destructed. But there is an instability, there's a dynamic instability, and there's moving here and there. So to control it, it has, there should be something that has been controlled from the ground, as well as it should have a capability to control on itself, so that it intercepts properly, or else it's the complete failure. Because if it misses out, the destruction happens, and there will be the target will not be hit, but it will be hitting the assets, the public. And that is why it is very important that it has certain guiding system for the terminal phase as well. Okay, and as the third point says, the greater the target acceleration, the more critical method of terminal guidance system becomes. Because yes, it is honestly true. It's completely true, because see, if a target is moving in a faster speed, it's very important that a missile should also attain the speed. I guess not only that speed, it has to attain 10x times more, so that it can match the speed of the target, and it can just destruct it and just break through it. And this is a small note for you. This is when a small short range missiles are used, there are single guidance systems which are used, like maybe one of it, like radios, or maybe cameras, or LORAN, long range, and maybe like normal one of these. Okay, thermal sensing, anything which is normal, which is one. Okay, but then when we use long range missiles, it requires lot many kind of guidances. It requires a lot many kind of guidances here, because it has to cover a long range. And that's the reason why it is very important to have much more different type of guidance systems in each phase. That is, for the terminal, for the initial, it requires some guidance systems. For the hovering, it requires some guidance systems, basically cruise. And for the terminal, it requires guidance systems. Okay, so till now we have come across the guiding systems, the fins, the grid thrusters, and the control altitude control system. Till now we understood this, and we have now understood how it moves around and how you can control a missile. Okay, now let us understand, we must learn how to command these guidance systems for a proper intercept and make it target oriented and target detonation. So let's about it in the further. So here I'll be calling John. I hope he's back. I haven't checked He'll be taking care of the types of guidance systems. From there, he'll be telling you everything. Okay, he's back finally. Thank you, John. I was waiting for you. You just
Most welcome, Devashish, and sorry everyone for the internet inconvenience. Okay, so okay, as far as Devashish would have cleared you up with how we can control it. Okay, like the fins part, the thrusters part, the actuator part, and the particular attitude control system, and the grid fins as well, like in the Falcon 9 system. Okay, so now I want you all to buckle up because we are going into really the core part of the missile technology. Okay, so how it's going to be? There's a small index again. There's separate kind of guidance systems. Now, basically, Deva has already cleared you with the guidance systems, but I would like to put some extra highlight onto it. See, the guidance system means how the system is going to be guided. How is it going to be controlled? Who is going to tell it that where to go, what to hit, what to see, what not to see, which paths to follow. Now, there are multiple methods of it. Okay, the most popular science fictional method is that the missile searches its target by itself. Okay, like you put, okay, let's say you put my photo into the missiles programming, and it will search for me throughout on the earth, and then wherever it finds me, it will destruct it. Right, so these are the different kind of, this is one of the guidance methods. Okay, so we are going to learn 3 different guidance methods. The first one is control guidance missiles. Okay, the second one is homing guidance. You might have heard about the system has active homing. The system is is a homing missile. So we are going to clear up that concept because we think most of people have a little bit of confusion into that. Okay, now if we are using something that is man-made, basically electromagnetic devices like radar, radio, something like that. So those particular missiles might have 2 categories into it. The first one is control guidance missile. The second one is homing guidance missile. And if we are not controlling it with any electromagnetic device, we are controlling with some other technology or something, like we'll discuss it, about it. Then there are 2 different categories again. The first one is self-contained guidance systems, whereas the second one is hybrid. But we are not going to learn hybrid. It's far beyond the scope of this seminar. But we'll be learning about the control guidance missiles, homing guidance missiles, and obviously self-contained missiles. Okay. Coming up to the control guidance missiles. Okay, now first of all, control guidance missiles means if it is being guided on the basis of the electromagnetic radiation. Okay, electromagnetic radiation even is the radio control. Okay, just like you fly a drone using your transmitter, right? So the similar kind of principle goes with these kind of control guidance systems. Okay, now using these control guidance systems, we can take information from our missile, like what it can see, what it can sense there, and we can send the data from our point, our control location, control station, to the missile. So there's a 2-way communication between them, and using this 2-way communication, we can guide the missile. Okay, now the first category into control guidance missiles. Okay, the first one into control guidance missile, because if the index is clear, okay, the path is clear, you'll better understand it. So I'm trying to memorize you with the index. So the first one is the control guidance missile. The control guidance missile is radar control guidance missile. Okay, this is too simple. I'll read out all this and I'll explain. But before that, I want you all to clear up with the thing that radar control guidance missiles or command control guidance missiles are nothing but you have a remote control in your hand. Okay, don't think of it as a remote control. Obviously, it's a control station. You'll see some pictures of the control station as well ahead. But you have a transmitter or you have a remote in your hand and you have a missile flying. Okay, and you can control the direction, you can detonate it at any point of time, you can calculate the interceptions, everything. Okay, but the control is completely manual, and in normal terms we call it as manual overrided system. Okay, so a guidance system in which complete guidance and commands, like how the missile is going to work and what kind of path is it going to follow, this all is completely guided by an external source. Okay, like just as I told you, with a transmitter, with a remote control that is outside the missile, some person is flying it. Okay, now the missile contains a receiver. Okay, and it can receive the data from the control station. Along with it, it can also send the data to the control system. Okay, now missile path basically does it converts these command to the guidance information, and then finally it goes to the attitude control. So that let's say if you are sitting at the control station and you want the missile to fly 80° north, so you will set your transmitter to 80° north and your missile will start flying to 80° north. So this is completely just like manual control. Okay. Now in this method, one or two radars are used to track the missile or the target. Okay. Now let's say we are talking about interception. Hope you are clear with the interception part. Okay. Interception is, I think you all have seen Mission Impossible 4 probably. So there's a cruise missile coming up and it's going to hit some particular area or particular territory. And there's another missile launched by our team. Okay. And it hits that or it collides with the incoming missile so that it destructs it up in the air and none of the public or none of the assets are damaged. So in that particular case, that is the whole scenario is called as interception. So in this particular radar control guidance method, one or two radars are used to track the missile, like sitting on the ground. Okay. Okay, let's take it as a scenario. You'll better understand it. You're sitting in your control station, okay, and you have a radar which is continuously searching for any kind of unmanned aerial vehicle or unmanned aerial object, maybe a missile, into the air. Okay, as soon as you see the enemy aircraft, enemy missile, or enemy drone, whatever, we'll call it enemy only. So as soon as you see the enemy, you track its location. Okay, and then you calculate it by yourself. There's no calculation system in the missile. You calculate it on your own. Not on your own means not manually using the calculator, means by the programming systems, but on the ground itself. So you calculate the interception path, you calculate the space or the coordinate in the up in the air, where if you redirect your own missile, it will eventually collide with the incoming missile and it will destruct it and protect your asset and public. Okay, so a radar is obviously logged onto the target. It's continuously searching for the target, and as soon as it detects a target, it keeps on sending the location to ground station. Now ground station calculates the interception path and the interception point, the most probable path where it will collide with the incoming missile and destruct it, and then similar kind of maneuvers. Okay, maneuver can be elevation, like how high the missile has to fly and what direction it has to fly. It has to go a little bit left, it has to go a little bit right. I'm just talking completely layman's language. Okay, so it has to go left, right, everything is decided by the control station. Okay, so this completely manual game kind of thing, just the way you play games. Okay, and the information that is coming from the target is being analyzed and the missile intercept flight path is computed. Now we'll see a system over here. In the lower below, the control system that you see is the complete manual. This is the actual image. This is not a drawn image. This is the actual image of the control station's joystick module. Okay, so on the right side, if you see, there's a joystick for the manual controlling. Like you can make your missile go up, down, left, right. Okay, and then you have the launch controls on the left side, the 3 buttons for the each phase, terminal phase, mid-course phase, and the boost phase. Okay, now what happens basically, let's say, and your system is equipped with a radar, okay, that is continuously searching for an enemy. The enemy is marked in the red rectangle, and that is a fighter aircraft. Okay, so as soon as it sees a fighter aircraft, it downloads the location of that particular aircraft. Okay, this is called downlink of the data. In downlink of the data, what all things will come? The position, like what are the coordinates where the enemy is flying, the bearing, and what is the height where it's flying. Bearing means the direction, angle, like 360-degree, just the way you calculate it with the compass. So you download all that data into your system. Okay, and then on the ground only, within this system, there's a programming system that computes the interception path. Okay, after that interception path is calculated, it is converted into degree, position, elevation, so that it is fed to our missile, so that it goes and collides with the enemy missile, and the data that is computed is now fed to the our missile that is marked in the green color. Okay, so the complete mind, or in this kind of radar control guidance method, missile is just a vehicle that's traveling from one location to another location at a very high speed, containing a high detonator charge. Apart from that, complete mind the interception, the computation, the data, position, coordinates, everything is calculated on ground. Now this is called as radar control guidance method. Now, once you understand one kind of method, others are a little bit of modification, plus or minus. So you'll better understand that. Okay. Second one is called as beam rider method. Okay. Now, beam rider method is major differences. See, that into that particular radar control guidance. First of all, you have to switch on your radar so that it tracks the system, and then you switch off your radar and then switch on the communication module to transmit the data to your missile. Okay, because now a lot of people would be arised up with the question like, why can't we keep on our radar and communication module switched on together at the same time? Because our radar will be sensing our missile as well into the system, and there's no way you can differentiate between two different missiles using just a radar. You need a visual image, you need a particular kind of code that's being sent onto ground. So that is a little bit of complex data. However, radar control guidance method is not being used anymore, like very frequently, but a few kind of systems still have them. Okay, so in beam rider method, what happens is the characteristic of missile tracking beam is never varied. Okay, what happens basically is, see, the computation was done on ground, right? This time the computation is being sent onto the missile itself. If you see the picture, you'll better understand it. Okay, now in the green, if you see that missile, there is a communication module and the obviously the communication is there through which it can talk to the ground station. Apart from it, it has the computation module there only. You don't have to compute the intercept location on ground. So the missile itself computes it. Okay, computation is okay, but we still need to know the coordinate and the actual position of the enemy. So what happens is the enemy aircraft data is being taken onto ground. Okay, and now there is no joystick. If you see, there is no joystick in the system because you can't control this system. All you can do is feed the location of the enemy to your own missile, and the missile will compute the interceptor path by itself, and it will fire onto the target. Okay, so there is no joystick into the system. So once there is a downlink of data and then there is uplink of the data, you don't need to switch between both of them. Okay, there's no two-way communication. So now what we are clear up with radar control guidance method, you take the position, you take the target position, you compute the interceptor path on your own, and you can maneuver it using the joystick. You can maneuver your own missile using the joystick. This is one thing. Beam rider method, you just take the position from the missile, your enemy. You just take the position of your enemy and you don't compute anything. You feed that particular data to your own missile. Your own missile computes the target, interception, where to hit, where not to hit, when to collide, when not to collide on its own. Now these are two control guidance methods. Okay. Now coming up to homing guidance missiles. Okay. If you have questions up, please note them down. We'll have a Q&A round probably in the last, so you can ask up all your questions over there. Now coming up to homing guidance missiles. Okay, the first one was control guidance missile. Why it was a control guidance missile? Because there's a ground station which is being involved into the system directly or indirectly. Okay, therefore the control is finally in the hands of the ground station. Now coming back to homing guidance missiles. Okay, now the first one is basically let's talk about homing guidance missile. So homing guidance missile has a has a sensor. Basically, we'll talk that it has a sensor that responds to electromagnetic waves, or that responds to a particular kind of each missile will be radiating some energy or some communication module through its own ground station, to its own enemy ground station. So we can sense that is there some vehicle which is sensing some kind of data that is not our data, or that is not something that we know already. So that will be considered as a suspicious vehicle. So homing guidance missiles have sensors which sense any kind of distinguishing feature of the enemy. Okay, and these missiles are very sensitive. How? They sense for radio frequency, they sense for infrared, reflected lasers. They send the laser, and if the laser reflects back with certain kind of data, that much sensitivity they have. They detect the sound, and they detect the visible light. Visible light means obviously the visible frame. They see it and they identify, no, it's not our missile, or whether it's our missile. Okay. For interception, two things are very important. The first one is elevation. The second one is azimuth. Azimuth, I won't, because this is too technical to be a word. Okay, so since you all are not from aerospace branch, azimuth we'll talk it about direction. Okay, direction or the bearing. So we'll talk about 80°, 90°, 360°, whatever. That's azimuth. And elevation, you, as you all know, the height. Okay. Now, how it comes, we have first category is called as active homing missiles. Okay. Now, this is a very important part because this category is the most widely used throughout the world. The first one is active homing missile, where transmitter and receiver both are into the system. So transmitter sends some kind of data, it goes to the target, reflects back, and the receiver receives it. Okay, just like, have you seen those robots that if you launch them onto, like, not actually robots, they're kind of toys that if you uh, you know put it on the ground, they'll go all the way along, and if they see a wall, they'll turn back. Okay, so how do they turn? They keep on sending the pulses, okay, and there's a particular time that they calculate of reflecting back, okay. And if the the transmitted radiation is reflecting back too early, they think the wall is too near, and they'll turn to some other side, to the left or to the right. Okay, so similar kind of data is being sent from transmitter. A radiation is being sent continuously, and then it is received by the weapon itself. There is no ground station. There's no ground station at all. These kind of missiles are also known as fire and forget missiles, just like Nag, okay, or Prahar. These are the most capable active homing missiles. Okay. Now the search and tracking is conducted by any tracking sensor. Okay, there can be multiple tracking that we'll talk about. Now target is tracked by, see, it's not tracked in a unidirection. Okay, it's not like it's searching on the particular direction, or it's just seeing in the front. Okay, there's a monostatic geometry. Monostatic geometry means a particular kind of geometry that remains fixed throughout the flight. Okay, but it is not looking straight through. Okay, and it keeps on sensing the data that is coming back after reflection, and it checks that is the missile too near, is the radiation the same as we sent, or is it our vehicle, or is it not, how the system responded. There are multiple kind of things. Okay, now after the data is received back from the target, onboard computer calculates a path so that it can intercept that. Okay, just like if you have an ultrasonic distance sensor, let's say we have a distance sensor. So if you put the sensor in your hand and you face it to the wall, okay, it will tell you that the wall is at 1.5 meters, right? Now if the wall is at 1.5 meters, you can calculate how fast you should throw the ball so that it just barely hits the wall, right? So similarly, if you have the distance, or if you know the distance that is coming from the target, the onboard computer calculates a course and the interception path, and then it steers or it maneuvers accordingly on the basis of weapon autopilot, because there's no ground station, and it can go and hit the target. Coming up to semi-active homing missile. Okay, now active is completely on itself. There's no ground station. Coming up to semi-active homing missile. Now target, see, an active homing missile, the sensor was equipped into the missile only. The transmission was also into the missile only. The receiver is also onto the missile, and along with it, the computation, the onboard computer is also onto the missile only, right? But in semi-active homing missile, the target is not illuminated by the weapon itself. There's a separate ground station that searches for the target. Okay, that keeps on sending the data or the radiation to the target, and the radiation sent is not reflected back onto ground. It's reflected to the weapon. Okay, and on basis of that, how long did it take from ground station to reach target, the radiation, and how long did it take to reflect back to the weapon, that kind of data and that kind of distance is calculated. And again, there's an onboard computer that searches for the when to intercept and what will be the position of interception and how to maneuver my system. Okay, in the first one, if you see, that is a active homing guidance missile. So and there's an enemy aircraft. If you look onto your left, it's our missile. If you look onto the right, it's a enemy aircraft, right? So what happens first is there's a ray that is being transmitted from our missile, and then a ray reflects back to our missile, right? After reflection, this is how it senses the distance and various kind of other kind of data about the enemy aircraft, and then maneuvers accordingly to go for an interception or directly hit the enemy. Okay, and as we know, onboard computer is onto the system. If you look onto the top, onboard computer computes the interception on basis of data received from the reflected ray. Okay, now coming to the lower part, see the lower segment, we have a semi-active homing guidance missile. Okay, now in the active homing, if you'll see, there's no ground station. There's just a missile and enemy aircraft. If you see on the semi-active homing guidance missile, there's a ground station there. Okay, so what basically happens now? Everything is same. The only thing is the missile won't be transmitting the radiation. The ground station will transmit the radiation to the aircraft, okay, and it will reflect back to the missile. Okay, and on that basis of reflection and whatever data is being received from reflection, that will be computed because onboard computer is still onto the missile only. Okay, the difference between active homing and semi-active homing is everything is same. Onboard computer is in the missile only, and it detects the interception on basis of the reflected ray. The only difference is active homing will itself send the radiation and receive it, whereas in semi-active homing, the missile won't send the radiation. Some ground station will send the radiation and it will reflect back to the missile. Okay. Now, there's a one good thing that we need to see. In extreme cases, the weapon may lose target, resulting in a missed intercept. Okay. If there's an extreme case, the weapon is moving with a very fast acceleration. There might be cases where there can be interception miss. The disadvantage, this kind of disadvantage of missing an intercept, is compensated by a greater power or high frequency illumination. See, the radiation that was going can be of very high frequency, okay, or very high wavelength. And these kind of changes, if we do into the radiation, we can cover a lot of range and a lot of area, and still we can compensate with the fact that we might not miss the intercept. Okay, so because we have some parameters that we can change accordingly for increasing the accuracy. Okay. So, okay, we have seen all this. Now coming to passive homing missile. Okay, passive homing missile is the most, how should I say? It's a missile that basically depends on whether the enemy wants to find us or find them or not. Okay, because it completely depends on the target as a source of tracking energy. How? I'll give you an example. Just like Deba was telling that you might have seen heat-seeking missile. Have you seen a dogfight? Not the street dogs. Dogfight means when two fighter aircrafts have a combat in air, that is called as dogfight. Okay. So what happens basically in dogfight is, let's say our aircraft is chasing the enemy aircraft. There's a scenario. Okay. And our aircraft launches a missile. Okay. Now you would have seen in probable cases that the missile keeps on chasing. Even if the enemy aircraft changes its direction, the missile will change the direction accordingly and go and hit the enemy aircraft, right? How does that happen? How is it tracking it? How does it know that it's the enemy missile and I should be tracking it continuously? Okay. The basic idea is there's a source that it sees into the enemy aircraft. What is it? The missile that is launched from our aircraft is equipped with a thermal imaging camera that senses the thermal visibility in the atmosphere. Okay. Now the whole atmosphere is cool, right? Everything is normal, nothing too much of very high temperature. There's one thing that will be high temperature, that is the enemy aircraft's exhaust vane, the nozzle. Okay, because it's sending the flame out, and obviously it is obviously the burned out gases. So the temperature of that particular part will be more than the complete different environment. So it will, since it's equipped with a thermal imaging camera, it will pursue for that particular thermal extension or that particular exhaust vanes, and it keeps on following the target, I mean the exhaust vane, till it destroys it or either it misses it completely so that it stops seeing it. Okay, now these kind of missiles are called as passive homing missile because there is no radiation sent, there is no control from the ground, there's nothing. The only thing is, if it sees a source or a energy source from the enemy, then only it can seek it, then only it can go and hit it. Okay, now tracking energy can be radiations or heat dissipated, as I told you, the exhaust vanes, by ships, submarine, aircraft engine exhaust or something. Okay, let's say there's a missile that destructs the ship chimneys. Okay, so how does that happen? Chimneys will probably have higher temperature than rest of the ship and ocean. Okay, so you design a missile that is searching for a high temperature. Okay, and as soon as it searches a particular kind of temperature, it orients itself to that direction and it goes and hits it. But only if enemy has left a clue behind. okay, or if enemy is giving some kind of source, then only passive homing missiles can be used. Now the disadvantage, it totally depends on certain amount of willing or unwilling cooperation from the target vehicle. Only if your enemy is going to cooperate you willingly or unwillingly, then only you will be able to use this kind of missiles. Okay. The fourth one is called as retransmission homing or track via missile. Okay. Now it is a blend of both radar guidance and semi-active. So you remember radar guidance? In radar guidance, we completely control the missile on our own using joysticks. And semi-active homing guidance, where the ground station sends a radiation to the enemy aircraft and it reflects back to the missile. I'll repeat again so that you remember that. Radar guidance method means, there's a complete joystick on the ground station by which you control your missile. Semi-active homing guidance has a ground station that keeps on searching and sending the radiation onto the enemy target, and it reflects back to the missiles. Okay. Now this is, retransmission homing or track via missile is a combination of both of them. How? Now the missile contains a semi-active seeker. Okay, from the missile, and it keeps on illuminating from the launch site or the from control point. Okay, obviously just like the semi-active homing guidance. Okay, and then the angles, whatever angles are being received after reflection, okay, those are coded onto the launch point. Okay, I mean with the downlink data, and then control center sends the required maneuver to the missile. Okay, so the computation is where? The computation is on the ground only. Okay, and this technique is used in some anti-aircraft warfare missile systems. Let's see if we have a picture of it. Okay, if you see that this passive homing missile, you all can guess in passive homing missile there will be only one ray, that is from the enemy to the missile, because if there's a source, then only our missile can work just like this. Okay, there's no other ground station, no transmission, nothing. Okay, now come to retransmission homing, you'll better understand this. Okay, now first what happens, missile, I mean the enemy sends some data, or the enemy data is being, why it's called as track via missile, retransmission or track via missile. So track via missile, you're for tracking, even for looking if the target is there or where the target is, you're using your own missile. So what happens, your missile detects or locates the enemy. Okay, so that data is being taken from the enemy aircraft to your own missile. Okay, first of all, it can be thermal radiation, picture, or electromagnetic wave. It can be anything. After that, okay, that data is being from missile, that data is being sent to your own radar. Okay, now your own radar computes the intercept on basis of whatever data your missile gave, and it sends back it to the missile, the exact maneuver. Okay, so like your missile is also working as a searching radar, because, and apart from it, the onboard computer is not onto missile, it's on the ground. I'll explain it again. Retransmission homing or track via missile, track by missile, because your missile is being used for tracking the enemy as well. So for tracking the enemy, it senses first of all, your missile is traveling up in the air, it sees some target. Okay, so it will transmit that location to your ground station. Your ground station will compute the the interception path or the position where it should collide, and then sends back that particular maneuver to your system, just like joystick sends it back to your missile, and your missile redirects itself accordingly. Okay, now each of these category has a separate kind of need in different kind of warfares. Okay, because it might depend on how much payload do we want. Okay, now if you see in retransmission homing, there's only one radar and one receiver. There's no onboard computer, there is no camera, nothing. Okay, so it reduces the weight. So if the weight is reduced, you can carry more TNT, more RDX, more detonator charge. Okay, so there are various cases where different kind of things are needed. Obviously, you can't use a Prithvi or Agni 6 missile just for destructing an aircraft. Okay, because it's a interceptor missile, so it has got that kind of particular need. Therefore, each of these missiles have their different kind of needs. Okay, that was part one. I mean, the control guided missiles. Okay, now coming up to the self-contained missiles. Now self-contained missile is too easy. Okay, it's like with the names only you can understand that. Okay, now self-contained means all the equipments that are required to go fire, find, destruct, everything is within the missile. There is no ground control. And as I told you, this is very similar to active homing guidance missile. and these are also known as, I've told you already, these are also known as fire and forget. Once you fire it, you forget it, because it will automatically find the target, will go destruct it, find its course, maintain it, and everything. Okay. Now, basically, it's for surface to surface missiles. Okay. Or electronic countermeasures. These kind of systems, they do not transmit or receive signals. As you know, everything is within the system only. They're not sending any data to ground station, and they're not taking any data from ground station. Therefore, you cannot jam them. There's no signal jamming into it. Unless you actually hit the missile and collide with it, you cannot destruct a self-contained missile. Okay. Now it has 4 categories. The first one is called as preset. The second one is terrestrial, inertial, and celestial navigation. All of them will be very clear by the name only. Preset guidance. The first thing is preset guidance. Okay. So preset guidance is like, I give you a missile, okay, and I give you a small keyboard, and I tell you put the coordinates where you want your missile to go and hit it. Okay. So you put latitude 28 degree and 60 minutes and something, and then you put longitude 40 degree this much. So whatever location you have put, it will go launch itself, and it will simply go and hit that particular place. Okay. Now preset guidance is only useful for stationary targets. Okay. Obviously it can't be used for interception, because if something is moving, how you're going to give that coordinate? Like, you have to feed the coordinate continuously, but you can't do that. So basically, if you want to destroy the enemy hangar, or a submarine that is stable, or some ship that is standing at the dock, okay, something that is not moving, so you give that particular coordinate to your missile, and it goes and hits that particular coordinate. Okay. The major advantage is, it's very simple. Obviously, there's no transmission, there's no tracking. You put a coordinate, and the GPS follows and goes and hits it. Okay. And it doesn't require any tracking or visibility. There's nothing like that. Okay. Now coming to inertial guidance. Okay. So inertial guidance is basically, okay, let's talk about a scenario. I give you a helicopter. Okay. Example, I give you a helicopter. By the way, just a small reminder that Perseverance will be landing today at around 11 or 12 p.m. Okay. So if you are a aerospace enthusiast, I would suggest you go and watch how does it land and how it's happening, whether the mission is successful or not. Okay. That was just a small update. Coming back, if I give you a small helicopter and I tell you there's no pilot into it. Okay. You have to go for the autopilot. So what would you do? Let's say that it flies at a throttle means acceleration of 70%. At 70% RPM of blades, the helicopter starts flying. Okay. But it will be falling to the left, right, front, backward, anywhere. Okay. How do you control that? So I put an accelerometer onto it. Okay. Accelerometer, or hope you all know accelerometer. Accelerometer is a system, or is a device which tells you the tilt angle or angle of deflection to any of the sides, x-axis, y-axis, or z-axis. Okay. So if you put it parallel to the ground, it will give you 0, 0, 0. Okay. And if you tilt it like 10 degree towards x-axis, it will tell you that you have tilted it to 10 degree onto the x-axis clockwise, or whatever way you are doing it. Okay. So if I put that kind of system into my helicopter, okay, and connect the control systems with it, so if I program it in such a way that if it starts going to the left, okay, or if my helicopter starts falling to the left, okay, the system will automatically tell that helicopter is falling to the left. Please, actuate it so that it comes back to its stable position. Okay. Now, similar kind of system is inertial guidance. Okay. This is just a refinement of preset guidance system. You have already given some data, right, into a system. Now, if your missile is not actually following the actual coordinates that you give, okay, you gave 38 degree and 40 degree latitude, longitude, and it's going 38 degree and 40 degree. Instead of that, it's going for 35 degree and 45 degree. Okay. So this kind of, mismanagement of the machine or the programming is being reset with the inertial guidance system. So what basically inertial guidance system is doing, it keeps on tracking that whether the actual pre-decided course is being followed or not. In case it is not being followed, your missile will redirect itself onto the target so that it it goes and hits the actual coordinate that you have feed it into the system. And basically it's very useful if you're flying through the windy locations, if the missile is going through the oceanic areas where there might be wind, breeze, hurricanes and cyclones coming up. Okay, so your missile might get deflected from its original position. So if it gets deflected, your inertial guidance system, a small accelerometer kind of system, that will keep on telling your system that you have deflected by 70 degree, please correct yourself to be on the right course. Okay, the third one is celestial or stellar guidance, as Deba has given a very short description about it. I'm sorry, I'm not reading out what's written there. More than that, I'm trying to explain because you all can read that out. Okay, now what's basically with this kind of system is, we have star trackers. Do you know that there are certain telescopes, even you can find them on Amazon. There's some certain kind of telescopes that if you tell that I want to see the polar star, okay, polar star you all know, okay, or dog star, Sirius. If you want to, you put into your system, into a telescope, obviously there's a programming small computer kind of thing given. So if you program that I want to see the pole star, okay, and if you put it onto the ground, your telescope will align itself with the help of motor. It will realign itself towards the polar star. Okay, and if you go and see into the telescope, you'll be seeing the polar star. So there are certain kind of star trackers that know where some fixed stars can be seen. Okay, so with reference to fixed star, okay, now if I tell you that, just like, have you all seen Man vs. Wild? There was a show on Discovery that it still goes on. That's Man vs. Wild, where it basically finds the direction only by using the stars or by the sun's position, moon's position, and something like that. In that particular scenario, when it searches that, okay, this side is the polar star, so this probably should be north. So rest of the sides might be west, east, and south, similar kind of thing. So if you can identify a particular kind of fixed star and take it as a reference, you will get to know all other directions. Okay, now let's say I have my missile should fly to 60 degree north of the polar star. Okay, so you keep a track of the polar star, okay, and your system will make sure that you're flying only to 60 degree towards the fixed star or whatever polar star you have seen. Okay, and we'll keep following that path. Okay, now the system guidance system is built in such a way that it detects the apparent position between the stars and the celestial body or whatever celestial body you have given. Okay, and with respect to point of surface on Earth. Okay, there's no GPS, it's completely onto the star tracking. Even in the aircraft, if the compass is loosed, I don't know how many of you know or not, there's a certain protocol that the first thing is you'll be using your own digital compass. If the digital compass is not working right, you'll go for the manual compass. If the manual compass is not going right, you'll go with the direction of sun. If sun is not right, you'll switch on your star chart and you'll track the polar star only to find the right direction. Okay, this is one of the procedures that's being taught into the commercial pilot license training. Okay, apart from that, now it's a highly desirable guidance system for long range. Okay, because polar star, I mean, not just polar, fixed star has a fixed direction always. Okay, nothing is changing, there's no visibility issue and these kind of things if you're flying exoatmospherically. Okay, because it has to track a star, you cannot fly under the clouds. Okay, because once you miss a particular star, then you have to retrack it and those kind of issues will be there. So it has always to fly above the clouds. And the missiles that basically fly above the clouds, like much above the clouds, are basically the cruise missiles that are intercontinental ballistic missiles or the ICBM. Okay, or they are SLBM, submarine launched ballistic missiles. They are also in the same category. Okay, now as I've already told you that the missile must fly above the clouds to ensure proper star visibility. Now coming up to the terrestrial guidance, this is going to be the last topic of the session, but this is very important. Okay, terrestrial guidance. In terrestrial guidance system, the basic idea is visuals. Okay, just like I gave you an example in the starting that if I feed my particular photo into your missile, okay, let's say you design a missile and you put my photo into the system and ask your system that wherever you find this person, go and chase it. Okay, So it will keep on searching every person's face and keep on matching them with mines, and wherever it sees a maximum match, it will take it as a target, and the coordinate will be fixed and it will hit me, right? So the missile guidance system has coordinates and visuals to both left and right side. Okay, apart from this terrestrial guidance, I want to tell you something. In the early days, like in 60s and 70s, this is a small story. In 60s and 70s, in the very early days, we didn't had that kind of interaction or that kind of system of cameras, right? And the if you all remember, there's you all know 5 MB hard disk was 1 meter by 5 meter in size. Okay, so you cannot store a lot of pictures. Okay, you cannot tell your system that if you see this person, this person, this person, go for it, because you have a limited size. And now you all know, like 256 GB and 1 terabyte is onto your small chip, right? So in the early days, there was some pictures that were feeded that was total of 5 MB, okay, into the system, and there was a camera that was fitted into the missile. So the missile kept on searching, it has the data feeded, it has the photos already feeded into the system. So it kept on following a path and keep on taking picture of the ground, and it matches that is this the ground or the ground terrain map that it's seeing, is it very similar to any of the photo that is saved into my system? If yes, it will follow the path. If no, it will search for the left side and right side and will follow the path where the photos match, where the current photo, live photo, matches the pre-stored data into the system. This method was called as terrain contour matching or TERCOM method. Those people who might have attended our previous session of image processing, we have told how to detect and like complete coding, how to detect, how to know, and what are the different methods of matching two contours and get to know whether how the target looks and how the target coordinate must be extracted. Okay, even the dronile that we talked about has been using similar kind of system into it. Okay, but tercom has only sufficient memory into it, okay, that finds, like, obviously, like I said, I just for an example, I said if you feed my face into the system, it might find me, but my face is very small for for matching a contour. So basically it can go for big size of areas or territories, like you want to destroy a large military base within a region. Okay, but you cannot destruct a particular aircraft within an airfield. Okay, you can destruct the whole airfield because it's a bigger area, it's easier to identify, it's easier to match from the live camera and pre-stored data, but it's really difficult to destruct a particular aircraft or a particular car with a particular number onto ground. Okay, that is still fictional kind of, but we are still trying it. Okay, in this guidance system, so there's some pre-stored digitized scenes, the pre-stored pictures that are already saved in the systems, and it is being compared to the television camera or the actual camera that is taking live pictures while flying. It matches both the pictures, okay, and according to the match, it determines the actual position with respect to the desired position. Okay, the missile can correct its path also. Like if the system doesn't matches to the pre-stored image, it might not go for it. If it matches to the pre-stored image, it originally gets to know that okay, this is my path and I'm following the right path because the images are matching. Okay, now this particular of saving the digitized image and then getting to know about the correction of path is called as digitized scene matching area correlator, and this is completely only and only into the defense industry, called as DSMAC. Okay, now DSMAC, what do you think? You launch the missile, and from the launch part and then mid course, I mean boost phase, mid course, and terminal, whole time DSMAC system or terrain contour system is on? No, the boost phase will be on some other control guidance method. Okay, maybe some other self-contained, maybe radar controlled, beam rider, or active homing, passive homing, track via missile. Okay, or semi-active homing. But DSMAC system will only be used in the terminal phase just a few minutes before the target is about to be reached. Okay, so that it can accurate itself apart from the coordinates, apart from the ground station data, apart from the reflected data that is just taken. The visuals can go a little bit better because your camera is itself a combination of multiple sensors into one. Okay. And another thing is, since DSMAC cannot go for very small characteristics, it cannot detect a very small picture or very small area. It can detect larger areas. Okay. Therefore, this is the reason, because the accuracy is not good. It cannot find a small stone in the ground, but it can identify a particular airfield, air hangar. Okay. Now, since it is not that much accurate, therefore it does not contain we do not equip them with conventional medium level explosives. Okay, we always put nuclear warheads. Okay, we haven't, but we can put nuclear warheads, because if nuclear warhead missile misses the target by 1 meter, 5 meter, or 10 meters, still the range of destruction would be so large that eventually the target will get destroyed. Okay, but if you miss the target by, like, let's say 100-meter, and the total detonation charge is barely of 50-meter, your target is still missing. Okay, and you have just missed a target. So TERCOM and DSMAC, obviously terrestrial guidance missile, basically uses nuclear warhead or warheads. Warhead means the explosive or the TNT. There are various kind of chemical charge, solid charge. I cannot tell everything because this is something towards it's my duty to the nation as well. So TERCOM and DSMAC, basically these systems require nuclear warhead or very high explosive detonator charges only. Now, TERCOM and DSMAC requires uploading, editing, because it matches the current image, the live image that it's seeing, with the images that are pre-stored. Okay, and pre-stored is not like you copy and you put .jpg and you save it into the folder. It's a complete different segment. Okay, it's a complete field of image processing where people do MTech of 2 years and then go on for their PhD. It's a big field along with it. Okay, so such kind of system can only be done by trained and talented personals. So you cannot equip a simple engineer for these kind of things. Okay, so terrestrial guidance is a separate entity that requires really good experience, good training, and good level of engineers to get into the system. Therefore, we have a limited amount of such kind of terrestrial guidance missiles. Okay, and this is a example of the TERCOM. Okay, so let's say the missile, the green colored, the green rectangled area is our missile, and it's flying through an area. Okay, and the camera is taking this picture that you see, the red color and green colored area. Okay, that just came up this part. Okay, now this is what the camera is seeing. Okay, now what camera is seeing is being matched with a pre-stored image. Now if you see on the top right side, there's a small image that is pre-stored into the system. Let's say that image is pre-stored into the system. It will match whether that area looks like the area that it is seeing right now. If yes, it will think, yes, I am following the right path. If no, it will think I'm following the wrong path. And since if people would have attended our last session on image processing, there's a particular small coding part that I will tell you. In the lower side of the picture, if you see, there's something written as cv2.match template. Okay, so this is a particular function of Python language that you can program it on your own. We have cv2.match template, and in that match template has two arguments. If you give it the missile live picture and pre-saved data, I mean the .jpg of the picture that you have already stored, and then .jpg of the current picture that it is seeing, it will tell you whether the system is matching with each other or not. Okay, and with this kind of systems, you can get to know about the uh, accuracy of the terrestrial guidance missiles. And that's the last part. And with this, I would like to end the session and hand it over to Sir. Sudeep, sir. Apart from it, if someone has some questions related to this session, you can go ahead and ask them.
Hello. Hello, guys. Am I audible? Yeah. I hope you guys, like everyone, understood about missile technologies and how it works. Thank you guys for the opportunity. And if there is any question, you can reach out to us. I'll be putting the details of. If you have any questions, you can contact us. Not a problem. If you want to ask any questions, you can ask me now. You can ask John Brown.